This is chapter 10. We are covering several sections at one time because they kind of all flow together. So if I ask you to graph a certain function, don't matter what the function is, you can always make an XY chart. Always, always, always. So for instance, this right here, just make an XY chart and start plugging in numbers. So if you put 0 right there, you know the square root of 0 is 0. Put 1 right there, the square root of 1 is 1. Put 4, the square root of 4 is 2. Put 9 in there, the square root of 9 is 3. And notice I chose certain numbers because I know the square root of 4. I know the square root of 9. I chose certain numbers that would work out nice. So if I graph 0, 0, 1, 1, 4, 2, 9, 3, and then I notice, like, if you try to put a negative number inside that, like if I try to put -1, you can't have a negative number inside of the square root. So you're going to end up, the graph is going to look like this right here. So you have, certain values that you want to do. You can always check this too. If you go to the square root of x, so the square root of x, and you push graph, let me just zoom 6. Okay, so see, it looks like that. And, as you plug in 16, even if I went to 16, I'm going to get 4. If I went to 25, I'm going to get 5. So it's going to slowly climb up. But I want you to notice there are no negative values. And by the way, I don't know why that's there, so that shouldn't be there. But there are no negative. If I plug in -1, it does not exist. If I plug in -2, matter of fact, look at the table. Let me change my table set. So if I look at my table, -1, you can't have -1, -2, -3, -4. You can't plug in negatives inside of a square root. So that's what the graph's going to look like for square roots. And if you remember transformations, I don't know why it keeps doing that. If you plug in transformations, this +3 right here is just going to shift it up 3 spaces. So instead of 0, 0, it's going to be at 0, 3. So it's shifting every single point up 3 spaces. So, and again, you could go to the XY chart if you want. You'll see it, but you got the square root of x, and then go outside the square root and push +3. And then if you look at it, see, it's just shifting. It's the same graph. It's just shifting it up 3 spaces. So it's going to look like this. And the same thing with this one right here. This is, if you remember transformation, this one's actually going to shift it 3 spaces to the left. So instead of 0, 0, it's going to be right here. And instead of 1, 1, it's going to shift it 3 spaces to the left. So, that graph, I apologize for that. That should not be there. I don't know why that keeps showing up there. But that graph is going to look like this. And again, if you go to the XY chart, the same thing. If you plug that in, the square root of x +3, and graph it, you can see that that all 3 graphs are being there. And this would just take it 3 to the left. This is 3 up. All right, so let's look at this right here. So again, I'm going to just use my calculator for speeding, just to get a little bit quicker. But you don't need a calculator. You can always just make an XY chart. So if I go to the square root of x minus 7. Now, again, I already know that that's going to be shifted 7 spaces to the right. Graph, you notice it's 7 spaces to the right. And if you look at the XY table, see there's error, error, error. But when you get to 7, it's 7, 0. 1. So it's going to look like this. Again, it's the same graph as this, but it's 7 spaces to the right. Now, if you look at this, that right there means I'm only interested, if you look at the XY chart, I only want 9, 10, 11. And all the numbers in between, like 9.1, 9.23, 10.7. I mean, I want only numbers between 9 and 11. So if you look at that, again, I only want those numbers right there, 9 to 11. So this graph will look like that. Again, here's x equals, whoops, so here's 9, x equals 9. So I'm only interested in the graph right there, and all the way here's 11. So the graph will look like here to here. That's literally all I want you to do, is I want you to graph only the x's that it's saying to graph. I also want you to point out that this is a closed circle. That's a closed circle. So if I had something like this, if I had that, then this right here at 11 would be an open circle. Okay, again, if that was that, it would be an open circle. So notice a closed circle at 9, open at 11. So here I have a function. It's a parabola. You guys know x squared is parabola. So if you come over here and 2x squared plus 3x minus 8, and I push graph, notice that's what the parabola looks like. But I'm only interested in the x's that are in that value. So if you look at your table, I only want from -1, so -1, -9, so -1, -9, 0 is -8, 1 is -3, and 2 is 6. So my graph will literally look like this. Again, the parabola is the entire thing, but I'm only interested in the x values that are from -1 to 2. And again, both of them are closed circles. If one of those was just like a less than sign, then that would be an open circle or something like that. So again, that's your domain. Domain is your x value, so I only am interested in the domain from there to there. Again, the same thing. I have a certain function, a cubic function. So here's y equals, and to do a cubic function, so if you press math, if you notice choice number 4, see I have the cubic function of x, and then plus 4. And then again, if you want to look at the graph, it's going to look like that. But again, I'm only interested in from -2 to 8. So if you go to your table, look at -2, that's 2.74. So -2, 2.7, about right there. And you don't have to plug in every single number, so plug in 0 to 4. So I know it's right here. 1, 5, I'm just kind of plugging in the nice numbers. And you definitely want to get to the very end, 8, because it goes all the way to 8. So 8, 6. And again, if you want to look at the way that it looks, so it's going to look like this. And I want to say it one more time. Those are both closed circles. So these are both closed circles. Okay, so that's all I want you to do is I want you to graph the function, but only the x values that I tell you to. That's restricted domain. So as a reminder, we went over this as well back at the earlier part of the year. To see if something is a function. To see if something is a function. Remember a function? Remember I told you about my elementary teacher that brought out the function box for every value that goes in? Remember the coin? If you put a certain number in, then a certain number comes out. So one number in, one number out. So think of it like an XY chart. If you put 5 in, then a certain number, like let's say -2, will come out. If I put 5 in again, then -2 should come out. But if some other value comes out, then that is not a function, okay? So one number in, one number out. Well, one way to tell this is by looking at the graph. You do a vertical line test. So if I draw a vertical line, notice it only crosses at one spot. Draw a vertical line, it only crosses at one spot. Draw a vertical line, it only crosses at one spot. This is a function. So let's go to this one right here. If I draw a vertical line, it only crosses at one spot. draw a vertical line on this one, it only crosses it at one spot. It only crosses it at one spot. It only crosses it at one spot. If I draw a vertical line on this one, notice it crosses at 3 spots. This is not a function. So these 3 are a function. This one right here is not. So draw a vertical line test, and we'll see if it's a function or not. So I also, if I ask you to evaluate a function, and again, this is a function right here. There's 2 ways to do this. We did this. We did this already at the beginning of the year as well. So f of 3 basically means I'm going to plug. This is the function f. This is f of 3. So if I put a 3 into the function, what comes out? So there's 2 ways to do it. You can actually just put a 3 in to the x and then work that out. The other way to do it is just go to your xy table and 2x squared, just plug the function in. And then just look at your table at 3. So at 3, it's 26. At negative 6, it's 53. At 0, it's negative 1. Again, you can plug them in manually if you want. This is just an XY chart. This whole thing is just an XY. If I plug 3 in, I get 26. If I plug negative 6 in, I get 53. If I plug 0 in, I get negative 1. So it's just an XY chart. This is your input. This is your output. Input, output. Input, output. This is your X. That's your Y. That's what a function is. One number in, one number out. Now, the same thing looking at a graph. So if I have f of negative 2, so this is the f function, okay? Remember, you just call functions f or g or h. And so that's the f function. So this is your input. So at negative 2, right there, where is the function f at negative 2? Well, it's right here. It's down at negative 1. So this is at negative 1. See, this is the point, negative 2, negative 1. So at negative 2, the function is at negative 1. So this one right here, let me use a different color. This is f of 1. So look at f of 1. So at 1, that's your x. Where is the function at? Well, it's right up here. See, this is the point 1, 4. So f of 1 equals 4. All right, and that's how you read the functions. That's basically the summary of chapter 10. I do want to emphasize too, I may ask you to read a graph. So if I have a graph, and again, if I have a certain graph that looks like this, I'm just making this up right now, and let's say that's negative 2, and let's say this goes to 3. And let's say that's a closed circle, that's an open circle. If I ask you to state the domain of this, the domain, there's 2 ways to write it. So it goes all the way to 3, from negative 2 to 3. In interval notation, that would be a bracket at negative 2 and parenthesis at 3. Again, we did all of this at the beginning of the year, so this is just a refresher. Again, reading the chart, the X line, you always look at the X line, that's your domain. Okay, so from negative 2 to 3. Again, that's an open circle. Now, if I ask you for the range is your Y. So look at your Y line. So the lowest that it goes, again, let's just say that's negative 1. And the highest that it goes, let's say that's positive 2. So it goes from negative 1 to 2 on the Y line. So negative 1 is an open circle, and 2 is a closed circle. Again, from here, the lowest point, see the function's right there, and the highest point right there. So from negative 1, open circle, that's why I have a parenthesis, and then a closed circle right here at 2.